They have until tonight to take the test. So I'm not going to discuss any specific questions on the test, but boy, am I going to give you a speech right now. All right. And no, it's a good speech. It's not you're in trouble type speech. All right, so here's the speech. You got to listen, though. You guys are kind of talking right now. So I choose, Mr. Chartier, I choose to teach algebra, solving equations. And this is the chapter, solving equations. I choose to teach it in a specific manner. I choose to teach it at a very low level. If you would have had me for pre-algebra and pre-algebra and algebra 1, you're like, Mr. C, you're using the same slides for the last 3 years. Yes, I am. Right? I choose to teach this for a reason. It's because I know where we're going. If you go to the Algebra 1 book, they start off with the complicated stuff first. And for many students who didn't master it last year in pre-algebra, we shouldn't be jumping to the hard stuff first. So I choose to teach the concept of how to solve an equation in a very simple manner. The simple manner is a one-step equation, right? Solving a one-step equation. The issue with solving a 5-step equation, which is where we're going, is that you do 5 one-step equations. I choose not to teach. Let's start off with a 5-step equation. I choose to start off with a one-step equation. So for most of you out there, unless you had me last year because I gave you the same speech, when you look at what I'm about to hand you, you're going to like, well, I already know the answer. I don't need to use your stupid algebra. I know the answer is 2. You need to put that in the back of your head and realize that I'm doing this for a purpose. And I want you to do the step. It's going to be ugly and painful today, especially for the bright kids out there, because you can look at it and tell me the answer. But I'm not teaching you how to solve a one-step equation in the sense of, well, can you get to the right answer? I'm teaching you how to do algebra so that when we get to a 5-step equation where you look at it and you're like, I have no idea whether the answer is either positive or negative right from the start, that you can do the procedures correctly, one step at a time. Each step that you take is one step. Therefore, it makes sense to start off with learning one-step equations. So for those of you who had me last year, we spent 2 days on one-step equations. Well, we'll only spend 1 day today. And then tomorrow we'll jump to 2-step equations. And then we'll do 3 steps, and 4 steps, and 5 steps. So we will ramp up quickly for those of you who look like and say, I'm in the wrong class. I already know how to do this. Well, you're going to confirm today whether you truly know how to do it, or whether you know how to show your steps, show your work. All right. I don't care that you, well, I do care, but I don't care that you can look at every one that I'm about to show you and tell me the answer. Great. That's not what I'm teaching you. I'm teaching the procedures of a one-step equation so that when we get to multiple steps, you're not completely and totally lost. All right. So when I hand this out to you, you're not going to say, this is stupid. I already know how to do this. Yes, I agree. You can already do this. You're going to follow along and you're just going to do the steps. And you're going to, even if you don't agree with it, you're going to understand that I'm doing this for a purpose, not to make your lives painful, but to make sure that you can do algebra. And the algebra we're doing today is solving equations. Right,
oh,
there's
goody.
the speech.
Oh my goodness. What's the homework?
This is so easy. Why did you do this to us?
It's exactly the same as last year, except where it ends. It's going to start the same way as last year, solving one-step equations. Last year we ended with a 3-step equation. This year we're going up to 5, maybe sometimes even 7 steps to solve one equation. All right, here we go. All right, quiet, please. So here's the calendar. All we got are classes this week. So we're going to do 1 steps today, 2 steps, and then we'll do, when we get over here, we're doing multiple steps. These are going to get complicated, really complicated. The word problems for this chapter are butt kickers as well, too. All right. So here, homework. What? This is conferences. I think so. Yeah. Did I not change? I'm confused about this right here. Everything up here is fine, but no, this is, yeah, I'm not sure why it says half day. I'm confused. But clearly this week is right and next week is right. I must not have changed this from last year. Yeah. There is absolutely parent-teacher conferences. It'll be on a Thursday and a Friday.
Do they have to go?
No.
Are you going to do the same thing you did last
You guys are asking too many questions about something that's too far in the future.
Don't snitch.
All right.
Don't be no snitch, dog.
Homework. I thought I updated that. I guess I missed that.
You never update.
Is it
Oh, I always-
conferences?
What?
Is it parent teachers conferences or student?
They're coming up. I don't know if they're there then or
Your parents have to go.
we'll talk about that as we get closer. Yes.
Are you going to ask the parents that need to come in?
Absolutely 100%. That is a fact.
So if you don't talk to the parents that don't need to come in.
Well, we haven't had that discussion yet.
Oh, yeah.
You guys are worried about stuff that's so
Hey,
far
you
out.
got us worried. It's your fault.
You got an A in the class. Why are you worried?
Hey, we just.
I go.
I'd like to
Because my
see.
mom doesn't need to go. The teacher's just going to be like, oh, yeah, she has good grades. And that's it.
Okay, do we have it all copied down? Here we go. All right. Now our voices are off. When you look at the section entitled 3.1, it doesn't say solving one-step equation. It says transforming equations. All right, I would much rather if they said to solve one-step equations because that's what they're teaching. Now, for last time, at least for 20 minutes, I need you to do what I tell you to do. There's a purpose for this. I don't care that you can look at the first question and say, well, duh, it's got to be 18. I'm just looking at it, right? Yes? Can everybody look at the first problem and tell me the answer is 18? Is everybody looking at box 3? And the answer is 18, obviously, right? All right. I'm teaching you how to solve an algebra problem. I'm using one-step equations as a method to get you ready to solve more steps. No, this is not a 9th grade thing, one-step equation. That's a 7th grade thing. But I'm using it as a way of showing you so I don't immediately jump into 5-step equations. All right, here we go. A quick note. Everyone look at the board. For this year, some of you, absolutely 100%, when you're solving an equation, should draw a line straight through the equal sign. All right? This will separate your equation into 2 parts. All right, the book will talk about LHS and RHS. That just means left-hand side, right-hand side. But absolutely, not today. We're doing a one-step equation. But when we get to a 5-step equation, it makes a lot of sense to draw a line straight through the equal sign. Some people hate that. Some people love it because it keeps things nice, neat, and orderly. Okay? All of these are called algebraic equations. They're called an algebraic equation because every equation will have at least one letter, one variable. Oh, by the way, you're in Algebra 1. We're going to get equations that have 2, 3, and 4 variables in it this year, not today. Okay? There are 3 key ideas in algebra. 3 main ideas of algebra. Look at box number 1. There are 3 boxes in box number 1. You're going to write them down in each box. 1 in each box. You ready? 3 key ideas. What is the main idea of algebra? Or solving equations. What's the main idea of solving equations? Say it again. Getting an answer. What does an answer look like when you solve an equation? What does it look like? And it doesn't look like a number. It looks like x equals a number. Bigger terms, we're going to call this isolating the variable, or in red is what you need to write down. You get the variable by itself. This is, Chris, write this down. This is how you know that you're done. I said we're going to get up to 5, 6, 7 steps this year. Well, how do you know you're done? You're done when it literally says, last step, x equals, and whatever is on the other side is the answer. Oh, by the way, smarty pants, what's the answer? Yeah, I thought so. You can't look at these and tell me the answer. We'll be on this in 2 days, right? But we're not going to start off with this. We're going to start off with simple ones so that we got the procedures down. But you're going to do algebra steps, step, 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 step. This one's a 3-step equation. You're going to do 3 steps, and eventually it's going to say x equals. On the other side of the equal sign is the answer. But your answer will never be 8. Your answer will always be x. What is the answer here, by the way? 4? Yeah. The answer will always be 4 or -4? It's 4. It's 4. It's 4. Yeah. So your answer would always be x equals 4. Okay. And for those of you that can't do that in your head, no, I don't expect you to do a 3-stepper in your head. Some of you can. Try not to do a 4-step or a 5-step in your head. It's too much work. But certainly you could potentially, at least in Algebra 1, get to where you could do this whole thing, this one, 3-step, in your head. When the numbers are nice and friendly, right? 2 times 4 is 8. 8 minus 10 is -2. Wait, that can't be right. It can't be 4. It's -4.
Told you.
Let's see. -4 times 5 is -20. -20 plus 2 is -18. 2 times -4 is -8. -8 minus 10, -18. It's -4. Okay. Okay, cool. So have we made it clear that some of you can't even do a 3-step in your head? 3 steps are a lot of steps, right? Key idea number 2, all right? You can do whatever you want to do when you solve an equation. Literally, even the wrong thing, as long as you do it to both sides. In algebra, we consider things to be balanced. That's what the equal sign means. The equal sign means whatever's on the left is the same value as whatever's on the right side. Now, clearly, they don't visually look like the same. 14 does not look like 2x minus 10. But the thing about algebra is they are the same, equivalent, right? No, numerically wise. Okay? So right now the equation is balanced. If we want to do something to this equation, you want to add something to one side, and you don't add the same thing to the other side, it's no longer balanced. It's like one of those scientific balance things, or maybe somebody lifting weights. If you take weights off or on one side, you got problems. Okay? All right. The last key idea is this. In order to do the first one, which is to get the variable by itself, it means we need to get rid of things. Literally, I need to get rid of stuff. Right now, I got 2 things that's keeping x from being by itself. This 2 and this -10. I need to get rid of the -10 and I need to get rid of the 2. If I got rid of those 2 things, then x would be by itself. Well, how do you get rid of -10? You add 10 not to one side, to both sides. So whatever you do to one side, you do the other side, and life is good, because 10 minus 10 is 0. I got rid of the 10. Okay? For those of you that need a visual explanation, right, is this a true statement?
Yes.
All right, well, let's add something to both sides. Is it still a true statement?
Yes.
Sure is. 12 equals 12. Does that work with subtraction?
Yeah.
Sure does. Does it work with multiplication?
Yeah.
And it certainly works with division. But, right, what happens if you don't do the same thing to both sides? What do you get? Non-inequality, right? It doesn't work. So you have to keep things balanced. I will show you, maybe not today, but I will show you that you can literally do the wrong thing in algebra, solving equations. Like maybe you're supposed to add 10 to both sides and you add 11. As long as you will add 11 to both sides, you'll still get to the answer. You created a little bit extra work for yourself. I'll show you this. But as long as you do it to both sides, life remains good. But if you don't do the same thing to both sides, you get some nonsense. Okay. So how do we get rid of things? We do what is called the inverse operation. So in red there. So to get rid of things, we do the inverse. Instead of subtracting 10, we add 10. Instead of multiplying by 10, we divide by 10. That's how you get rid of things. Do you remember doing this, those kids that I taught last year? Remember writing this down last year? Okay. We wrote it down 4 times last year, 4 different days. That's why you remember it. So by the time you get to Algebra 1, you've seen this technically at least 2 years. So this is why in Algebra 1, I only make you write it down 1 time. Now, once again, for those of you that had me last year, I have a method of doing all algebra. And just like for adding, subtracting, I say, hey, same or different signs, add or subtract, right? More positives, more negatives. I have the same thing for solving equations, right? Oh, by the way, let's talk about the inverses. What's the inverse of addition?
Subtraction.
What's the inverse of subtraction?
Addition.
What's the inverse of multiplication?
Division.
What's the inverse of division?
Multiplication.
You're in Algebra 1. You're going to get more of them this year. Did you know that there's more than that?
Yes.
What's the inverse of squaring?
Square root.
Square rooting. What's the inverse of cubing?
I don't have no clue.
Cube rooting.
I've never
All
heard of that.
All right. You shouldn't. It's new for this year. So last year, you only had these 4 inverses. This year, you're going to get a couple more. What's the inverse of absolute value? There's another one that you'll get.
Negative absolute value.
It's pretty close, right?
The opposite of absolute
It's
value.
the opposite of absolute value. All right. So we got these 3 key ideas. Lastly, the last one is to get rid of something, you do the inverse. And trust me, for those of you that are good at solving equations, this is what you do, by the way. Remember, this is our goal. Once again, I know that all of you can look at this and tell me that the answer is 3. But when I teach today using this simple one-step equation, I'm teaching you the process of solving, not, oh, look at a simple problem, get to the answer. All right. For those of you who had me last year, this is how I solve all algebra. These are called the steps, box 2, the steps of solving algebra problems. You will always go through this script. It's a script. You ask yourself, is the variable by itself? Guess what happens if the answer is yes? You're done. But the answer will be no most of the time, until you're done. So the answer is going to be no. So you go to the next question. Well, if the variable is not by itself, there's got to be something attached. When there's a 7-step equation, there are 7 things that you need to get rid of. When it's a 1-step equation today, there's only 1 number you need to get rid of. Once you've identified what you need to get rid of, you need to figure out how it's attached to the variable. It's either going to be attached by addition, subtraction, multiplication, or division, at least for this chapter. Eventually, we'll talk about absolute value and squaring, square rooting, that sort of thing. Once you've identified what's attached, how it's attached, to get rid of it, you do the inverse. So just like adding, subtracting positive and negative numbers, you'll hear me say a script. This is the script. I'll just say, you'll say, I don't know how to solve this. And I'll say, where's the variable, left or right side? You'll say, right side. We'll say, well, what's attached to it? You'll say, oh, there's a 2 and a 10. And I'll say, well, pick one. Which one you want to get rid of? And you'll say 10. I'll say, well, how is the 10 attached to the variable? Addition. Well, what's the inverse of addition? Subtraction. So subtract 10 from both sides. That is the script that I follow. I don't have any kid that can't solve an algebra problem, solve an algebra equation, when I say these magic words. These are the magic words. The issue I will have is some kids are like, well, they want to go off the script. They want to do their own thing. Just follow the script and your life will be good. Today you will not be impressed because it's only one thing to do each and every time. I'm going to bet that you had good math teachers that you're going to do it exactly the same way that I do it. But if it's not, please tell me. We'll talk about it, whether I say, yeah, that's a good way or a bad way. All right. All right. So here we go. First one. This is a 7th grade problem, not a 9th grade problem. Okay. So here we go. Here's how it works. Porter, where's the variable? Left or right side? It's on the left side. Porter, is the variable by itself? Is it by itself, or is there something else with it? The 2 is with it. And you're like, what about the 5? The 5's on the other side. But we're talking about the side that has the variable, has a 2 attached to it. Porter has a 2 attached to the x. It's attached by addition. Can everybody see that? 2 is being added to x. So how do you get rid of add 2? And whatever we do to one side, so what are we going to subtract from both sides? So we're going to subtract 2 from both sides. All right, old kids, you already know how to write this. New kids, did your math teacher tell you to write it like that? Yes or no? When you subtracted 2 from both sides, you had a good math teacher. Sometimes, in even our math book, I don't like it, they will tell you to do this. They will tell you to write x plus 2, and then next to it, write minus 2, equals 5 minus 2. There's nothing inherently wrong with that. It's just too much work. It's easier to write minus 2, draw a line, and do the math than to rewrite this whole darn thing. The book will show you this, though. They won't show you this. They'll show you this. I want you to do it this way. It's way more efficient. And we're in Algebra 1 now. We need to be efficient. And we're doing a 5-step equation. All right, let's do the math. 5 minus 2, Piper. 2 minus 2. So technically, the x didn't go away. Technically, if I look at the board, 2 minus 2 is a 0. So it would be x plus 0. And 5 minus 2 is 3. Except, what is anything added to 0? Itself, so the actual answer is, now you're going to see me write this step. You look at the board, you're going to see me write this step a bunch of times. This is for 7th graders. For 9th graders, you already know we do an inverse operation to make it go away. It's gone. We don't say cancel for addition subtraction. Cancel is for multiplication, right, or division. We just simply write. So you're okay with writing this. You're looking. You need to write that. You need to write this. This is, I'm going to show you this at least for a couple days, and then I will stop doing it. Okay. This year, and this year only, right? You didn't see this last year. We will need to be able to know how to do something called a check step. When you do 5 steps, how do you know you got the right answer? It's a guess. It's like, did I make any mistakes? There's only one way to figure out if you make a mistake. It's called a check step. We take the answer, which we said was what? X equals 3. We said that we think that x equals 3. A check step is where you take the answer, you plug it back into the original equation, and you see if you, in fact, got the right answer. Well, how do you know? Well, the left side must equal the right side. What's 3 plus 2? Well, 5 does equal 5. That's how you know. Now, granted, doing a check step on a 1-step equation, it seems stupid, right? It doesn't seem silly when you have 5 steps. Then maybe it makes sense. So this is the year that you might, when you have time, want to do a check step. Not on a 1-step equation, though. All right. Once again, the verbiage goes like this. Where's the variable? Left or right side, Nathan? I'm looking at just the left side. Is the variable by itself? Okay. By itself means the only thing that you see on the left side is x. Oh, what's attached to it? What's attached to the x? The 6. Mathematically, how is the 6 attached to the x? Mathematically means add, subtract, multiply, or divide. It's attached through addition. Literally, it says x plus 6. Well, how do you get rid of addition? What's the inverse of addition? So what are we going to subtract from both sides? The thing that you're trying to get rid of. What are we trying to get rid of? 6. So what are we going to subtract from both sides? See what I did? Chris, 4 minus 6.
What you did?
4 minus 6? No.
Yes, you said 4 minus 6.
I did.
No.
You said 2.
No.
Same or different signs? Different means add or subtract.
Means
So subtract the numbers.
4 minus 6 is,
Well, it's 6 minus 4, big minus small.
oh,
6 minus 4.
I don't want to see this training.
6 minus 4, you can do this,
Okay.
is 6 minus 4. You can do this. You're not confused by 6 minus 4, believe me. Subtract 4 from 6. Stop. Plus, you're yelling the wrong answers, too. Right? 6 minus 4. Count. Here's 6. Count down 4. 1, 2, 3, 4.
2.
Okay, more negatives, more positives.
I mean, just more negatives.
So therefore, the answer is? All right.
It was telling you to. It's saying no.
Because the answer isn't 2. All right. No, when I said what's 6 minus 4, those bozos are yelling negative 2. 6 minus 4 is not negative 2. Thank you, bozos.
Wow.
Now, seriously, when I'm trying to help someone, it's not helpful to yell at the answers, right?
Especially when it's wrong.
Especially when it's wrong.
Especially when it's wrong.
All right. This is the step that I show all 7th and 8th graders, but for 9th graders, we already know that 6 minus 6 is 0, it goes away. The reason we subtracted 6 from both sides was purposely to make the 6 go away. So you do not have to write the step that I'm pointing to right now, but you do need to write this and this. And you have to be able to do the math correctly, okay? So we fight 2 battles in algebra. The first battle is, how do I solve the equation? Okay, these are easy. They won't be easy when we get to 5 steps. And the second battle is, you got to do the math correctly. Hey, guess what? If you're doing 5 steps and you screw up the first one and you write +2, guess what? Every other step past that is wrong. Math teachers like to write math problems, right? We have to grade your work, right? So guess what we like answers to be?
Right.
Well, clear, but I'm saying, guess what we like the answers to be? Do we like the answer to be negative 1.732? Or would we rather the answer to be -1? When we write, no, not rounding, when we write math problems, when people write math books, they will make what are called friendly answers, right? If you're doing 5 steps and the first one is wrong, guess what you will get? You will get a very unfriendly answer. And this is when I get, Mr. C, I was doing step 4 and I get this like repeating decimal, or it goes 8 decimal places. Yeah, because you made a mistake, right? I'm not going to do that, nor do they do it in a math book. They write friendly answers 99 out of 100 times. That one time it might be an ugly answer. Those are usually word problems. Okay, here we go. A quick note. Do you see what's being done here? What's being added to x? What's being added to x?
7, sorry.
What does this sign go to, the 7 or the x? What does this sign go to right here, the 7 or the x? Well, I'm not hearing anybody say anything. Does this x, does this plus go to the x, or does it go to the 7? So when I say, how is the 7 attached to the x, this plus doesn't mean it's attached by addition. It's this plus means it's attached by addition. And the issue becomes is when this one is -7. You see it? What number am I trying to get rid of now? 7 or -7? How do you get rid of -7?
You add 7.
This one right here will cause people to think I need to subtract 7 from both sides. This plus belongs to the x. So when the numbers are flip-flopped, when it goes number variable, be very careful. Always look for addition subtraction to the left to see what's attached. Oh, it's a -7 attached. We'll get rid of -7. I need to add 7 to both sides. So just be careful on these. And I know we're still just doing a one-step equation. You can look at it right now and just tell me the answer is 3. I also need you to do the steps, even though we're doing one-step equation. By the way, what's the answer? This is in 3 days. What's the answer? Anybody?
Wait,
You can't do this one in your head.
I could.
But this is just a bunch of one-step equations put together. This is 1, 2, 3, 4, 5. This is 6 steps to get to an answer. This is where we're going in just a few short days. If you can't do the steps for 1 step, you can't do it for 6-step equation. 6-step equation is just 6 one-step equations put together. You'll see when we get there. All right, here we go. Where's variable, left or right side? Okay, what's attached to it? What's attached? There's a 3 attached. How is the 3 attached to the x? How do we get rid of addition? What do we subtract from both sides? So we subtract 3 from both sides. 21 minus 3 is, so therefore the answer is, wait, why doesn't it say x equals 18? Because the variable was on the right side to start with. The book will almost always flip-flop these around for the final answer. Rarely will the book say 18 equals x. The book will typically say x equals 18. So be ready for that. Yes. Doesn't matter. Does not matter. Okay, you got 4 problems. You got 30 seconds. Go. 4 problems, 30 seconds, because most of you have already done these while I was talking. And remember, these are just one-step equations. This is not a ninth grade thing. This is just, let's make sure that we're all doing solving equations the same way.
I didn't.
Yeah, you didn't write any steps. I need to see the steps. The purpose of today is to learn how to do the steps. It's not to do math with silly problems, which they're all pretty silly. If you don't write the steps, you can't do. Tell me what's the first thing you do, Tristan?
I don't know.
That's what I'm saying. But if you can't write the one step, then how are you going to do a 6-step equation? You got to write the steps.
I could do that.
You will by the end of the week.
I'm gonna quit.
It's pretty simple.
I'm gonna just drop out. Can I drop out of this
It's
game?
illegal till you're 17.
You talk to your parents. That's not a conversation I want to have with you. I would encourage you to stay in school, though. All right. Here we go. First one. Who's got the answer? X equals, what do you got, Sierra?
-9.
-5. If we subtract 7 from both sides, 2 minus 7 is not 5. It's -5. All right, bottom one. What do we got? X equals 4. Very good. Top right. X equals 9. Bottom.
-14.
All right, we got this? Did you hear the conversation I had with Tristan? Tristan had the right answers, but he didn't write this thing. This is what I'm teaching you, is how to write, how to get rid of addition. Hey, guess what? All of these were addition. Guess what we're going to do now?
Subtraction.
All right, let's do some subtractions. All right, once again, this is 7th grade. This ain't 9th grade. Nathan, where's the variable, left or right side? What? Okay, is it by itself? What's attached to it? How's 3 attached to x? How do you get rid of subtraction? So what are we going to add to both sides? Boom. 21 plus 3. You got 15 minutes. Okay, so therefore the answer is? Agree, but the answer is? Perfect.
I did the step.
Perfect. Got it?
Yep.
All right. Check step, we would take 24, throw it back into the equation. 24 minus 3 is 21. Check. Done. Correct. All right. Real quickly, here we go. Piper, where's the variable? Left or right side? What's attached to it? How about 10? I'm looking for a number. 10. How is 10 attached to x? How do we get rid of subtraction? What are we going to add to both sides? And we would just say add 10, right? All right, so let's add 10 to both sides. What's 4 plus 10?
14.
So what's the answer? There you go. Chris is like, why didn't I get an easy one like that? Why'd you have to give me the hard one? All right. All right, Chris. You ready? Okay, where's the variable, left or right side? Is it by itself, or has it got something attached to it? How is 8 attached to x? How do we get rid of subtraction? What are we going to add to both sides? So both sides. The reason I'm circling the x is because for 7th graders to say where, they can't tell their lefts from the right, so I got to circle. All right. All right, Chris, here we go. You ready? Same or different signs. Add or subtract. You need this in front of your face so that you have this in. No. All right, subtract 2 numbers.
Oh, sorry.
More positives, more negatives. So the answer is, final answer?
No, sorry. X or no 4. Just okay.
You almost got it.
No, it's already been
We already agreed it's positive 4. What's the answer?
4.
X equals 4.
Oh, okay.
X equals 4. Now, did I write that as x equals 4?
Yep. Backwards.
Now, why did I write mine backwards?
Because that's
Let him answer. Let him answer. Why does mine say 4 equals x? Where was the variable originally? On the left or the right side? That's why mine says 4 equals x. But when you write it, right, and the book writes it, they'll say x equals 4. The answer to solving any equation will always be variable equals the answer. Give me a thumbs up or thumbs down if you think you're, at least you kind of know the process. Okay, good. I think you do too. All right, you ready? This is the one that will kick everyone's butt. Do you see it? How is this number attached to x? Doesn't it look like addition? It ain't addition. X is attached to -3 by addition, but how is 3 attached to x? It's attached by subtraction. We look to the left for adding and subtracting. So if I look to the left, it's -3. So how do you get rid of -3? If you had said, well, let's subtract 3 from both sides, what's -3 minus 3? -6, you did the wrong thing. Okay. Now you just made yourself more work. But most kids don't even realize they did it wrong. They just consider 0. Okay, so what are we doing to both sides here?
Adding 3.
We're adding 3 to both sides, therefore x equals. Are we okay? This is the one that will kick your butt. I mean, even when we do, 2 months from now, we're solving equations, this will still kick your butt if you don't pay attention. All right, we got 4, do them. And then we're almost done.
3 boxes at the bottom.
There's 3 boxes. Well, fine, sure. There's nothing in there. That's why they're not labeled. I don't do extra work, so I'm not going to delete them or something like that. That'd be extra work.
I didn't have that. I taught myself how to
You're so smart, yeah.
All right, anyone need help?
No, we're smart like this. We learned this like 2 years ago.
You did. And you did it last year as well, too. Literally the same slide. I don't change. This is the same slide I use for all 3 classes. I only change it when we get to 3-step equations for algebra. All right, here we go. Julie, first one, x equals? 11. All right. Mike, bottom left, what do you got? Mike Cole. Well, he perked up when I said Mike. He knew who I was talking to. What do you got? X equals? Bottom left. Where's the variable? Left or right side? What's attached to it? So how do you get rid of -6? So let's add 6 to both sides. So therefore x equals 10. All right. Harder one, Rowan, go. Okay, or x equals 3, right? Notice now I did flip them around, right? We good? Who wants the last one? It's the hardest one. Sophia? No.
Which one? What question?
I was being facetious. X equals 9. All right. We got this.
Yeah.
All right. So my claim was this. My claim was you're going to look at this and say, well, this is silly. This is just way too easy. This is not algebra. It's not algebra 1. But it is a gateway into algebra 1, meaning that the steps that we took, how to get rid of addition, subtraction, tomorrow we'll do multiplication, division, how to get rid of addition, subtraction, we gotta be able to write it this way. We gotta understand it this way so that we get to 6 steps, which we will do by the end of the week. Maybe not 6 steps, but 4 steps for sure by the end of the week, that you're okay with this stuff. Okay? All right, you have a mixture of addition, subtraction, last box, go. And then we're done. It's a mixture of addition, subtraction. Steps. Write the steps. You did them all wrong, by the way, Tristan.
I did it before we started instructing, but I did this one.
Yeah, but do the steps. Don't look on the other paper. Look, where's the variable, left or right side? What's attached to it? How is 7 attached to x? No, that's how to get rid of it. So show me. Subtract 7 from both sides. -7. -7. Now do the math. Now write the answer. No, that's not the answer. How do you write all the answer to all algebra problems? Write that. You're not saying that the answer is 3. You're saying that the variable x is equal to the value 3.
My God.
You still haven't. Oh, there you go. Okay, now do this one. We good?
My brain is collapsing down. So.
All right. Kaylee, first one, you got it? X equals 3. Good job. Oops. Sorry. X equals 3. This one, who wants it? Go for it. X equals 88. Top right. Ooh, that was a harder one. X equals -6. And the bottom left, bottom right, sorry.
15.
X equals 15. Hey, do the steps.
Yeah.
This is where we're going. Anybody solve this one yet?
Oh wait, I think I know.
I solved it.
I'm pretty sure.
Wait, which one's that one? Never mind.
3x plus 4.
Wow. All right. What do you immediately see right here?
Distributive product.
So do the distributive property. What do we get? -2x minus 10 equals 5x plus 6. When you have variables on both sides, get rid of one of the variables. What do you want to get rid of? 5x or -2x?
Negative 2x.
So add 2x to both sides.
7x plus
-10 equals 7x plus 6.
minus 6.
So you get -16 equals 7x, therefore x equals -16/7. There's an algebra 1 problem, baby. Right there. Notice that we get an ugly answer at the very end, but you don't do ugly math until the very end. Right? All right. So this is where we're going. We're going here very quickly. And this is a very easy problem. But notice every single time I just did one step at a time.
We're only on the first space. Calm down. You ready?
Well, I had to stimulate the brains of some of the quicker students so that they were not get worried that I'm not going to teach them anything challenging this year. Yes. One more time. All right. Everybody look at the board. That's a good question. Last 2 notes, because I knew you were going to guess this question. Last 2 notes. For homework, you might have something that looks like this. Guess what your first step should be?
10 minus 2.
How about we simplify both sides and we do 10 minus 2? What is 10 minus 2?
8.
And then you can solve it from there. Okay? All right. This is the one that they're questioning right here. Look at the board. It looks like it's a 1-step equation. This is actually a 2-step equation. All right, here we go. You ready? What am I trying to get rid of?
5. So you minus
So
5.
look to the left. Is it 5 positive or negative? So how do we get rid of 5?
Minus
So I'm going to subtract 5 from both sides. And we get, be careful,
negative x equals 2.
we get -x equals 2.
And
Does
then
it,
you divide by -1.
hold on there, smarty pants. Does it say x or does it say -x?
Negative x.
Okay, so it turns out that there's a hidden 1 right here. How is this 1 attached to x? How do we get rid of multiplication? So we're going to divide both sides by -1. Negatives cancel, and you're left with x equal to -2. I'll give you another explanation. Here's a harder explanation. So we got -x equals 2. Check it out. Let's add x to both sides. What's x minus x?
0.
0, right? Equals x plus 2. Now what do? Subtract 2 from both sides, and we get x equals -2. Same answer. That is so much more work, but what it shows you is what happens. Now, let me wrap this one up. So what happens, I showed you 2 different ways. They both require a lot of work. You're not paying attention, Kristen. When you get -x equals 2, we can immediately jump to the answer because we saw the pattern. You get rid of the negative, what happens on this side? It turns opposite. So the answer was x equals -2. So if it says negative x equals -3, you just write the opposite. X equals +3. What are you really doing mathematically? Well, two explanations. You're either dividing or multiplying by -1, or you're adding that x and then subtracting. Okay? Those are your two examples. So this is the one that's on homework, Julie, right? So what do? Both sides. Trying to get rid of 4. Subtract 4 from both sides. We get -x equals 6. Therefore, the answer is x equals -6. Now, you can think of that as either I'm multiplying everything through by -1, or I'm dividing by -1, or I'm adding x to both sides and then subtracting 6. Either way, right? I'm a negative multiply by -1 type person. Negative times a negative is a positive. So we get x equals -6. The division thing is just too much to write for me. I also skip that step and just simply write x equals 6. -6, sorry. We good?
Yep.
Thank you, Julie, for asking that question.
Wait, no.
I'm not. What I'm showing you is that when this is the question, that's the answer. What's happening? You write the opposite of both of these. In Algebra 1, we don't do that step. We just immediately write the answer because we understand that's what's going on. In 7th and 8th grade, I make them write that step. But 9th grade, you're like, oh yeah, well, x is equal to 6. -6, sorry. Keep saying it backwards. Good? Last 2 notes. What am I saying here? Just another example. Chris, 2 minus 4.
So, wait, 2 minutes. Wow, okay, hold on. I know you just got the question right.
Same or different signs? Subtract. Subtract. More negatives, more positives. More negatives or positives. So therefore, all right, e-learners, that's it. We're eating lunch here. If you have any questions, send me an email. If you need any help tutoring, that sort of thing, don't hesitate to ask for help. Haley, as always, good to see you, and we will catch you tomorrow. Make sure you did your test, Haley, if you haven't taken it.
I will. I just printed it off, so I'll do it today.
Oh, sweet. Sweet. Sounds good. Good luck.
Thanks.
Later.